Check. Another couple minutes to find us. I think the room seems about 190. I think there's about 190 people enrolled in the course. I think there's about 190 numbers. About 50 people on the wait list. So probably have an eye. This is Compute 201. Yes, okay, nobody left. That's good. So today we're going to talk about welcome, what to expect in this course, laying out the way it's structured, what to expect, how much work it is. A few little announcements. There's no labs, a lot of TA office hours this week. There are a couple things already due on Sunday coming up. Talk a bit more about them, but Lab 0 is just get the tool up and running. You might think that's a gimme. It's actually maybe an hour or 2 hours worth of work, depending on how much experience you got with the tools from before. So we'll get on to that, walk you through what that is. Also, assignment 0 is again due on Sunday. It is the first half of the course has 8 small assignments. We call them small assignments. Really, they're tutorials. They're tutorials that we're forcing you to walk through. The first of which, I believe, is on the command prompt. So a Linux command prompt. It forces us all to have the same sort of base level of skills. And that is due on Sunday. It's actually not due Sunday. It's really due the same day as assignment 3, because with 0 index, that's the 4th assignment. And the reason we're doing that is so that anyone who joins the class late doesn't have to worry about did I miss something or not. Everybody gets an automatic 2-week extension on the first couple assignments. And that helps us get on board. Just don't let it get ahead of you. It's not like you can rest, do nothing for 2 weeks, and then start. I could ask, how many people have ever had a semester where they were busier in the first week than they were in the last week of the semester? A couple of us, oh you have, okay, that's good. Most of us have not, right? Most of us, the first week is not a lot of work, and then the last week is huge amounts of work. And so that's pretty true, I guess, for most classes. So plan to try and get into the material fast, get working on that. And also put up a little cartoon. So this week's one is, I'm really into writing short fiction. Mainly I write to-do lists. That's my fiction. That was a joke, they're really funny. Good. Most of them will be Star Trek, which you may appreciate or you may not, and we'll go from there. Okay, so we're talking about systems programming. What is that? Basically, it's writing the low-level stuff. The really cool thing about programming and computers in general is there is no magic. From hardware all the way up to the top, there is absolutely no magic in the system, and every step of the way can be fully explained. It gets a little weird when you start talking AI systems that are running. You can fully, I don't know if like explains the right word, you can tell how they did it, you might not understand it. So AI systems are maybe getting to the point of being not understandable. So, lectures will have hopefully quite a bit on interaction. I've got an app that I'd love everyone to download. It's called the ABCD app. And I will give you the world's shortest demo. During lecture, I will put up 4 multiple choice questions, and everybody gets to think about it for a moment, and then I'll count it down. Okay, everyone vote in 5, 4, 3, 2, 1, 0, and then we all show at once what we think the answer is. And I look around the room and I see a sea of A's. Of course, the answer is always C, so we know we don't have the wrong answer. Anyway, so we'll kind of work that through. It's a fast way of me seeing how many people are thinking which way or the other way. Oftentimes, there'll be a couple answers that look pretty good, and this is kind of a low-stress way of just kind of participating in lecture. No, I'm not taking marks. No, you don't have to pay for it. You just build a little bit of collaboration. So hopefully you get some of this today. Please download whichever one of those you think you can run on your machine. So today we're going to talk quick introductions to what's going on in this course. We'll look at what is systems programming and get a feel for that. An overview of what the activities of the course are going to be, and then hopefully I can demo the coding environment. That'll be kind of the first hour, pardon me. Of course, we do have 2-hour lectures Monday and Wednesday. The next hour we'll get into a bit more of the content. So who am I? I'm Dr. Brian. I'm Dr. Brian Fraser, really, but you want to call me Dr. Brian. A couple photos of me. I had 10 years experience working in industry. A lot of things I worked on were embedded systems, so small little things. These here, for example, we put all of these batteries into this autonomous submarine. I didn't write any of this code. I wrote the control software for the batteries, and we then put that into and explore the Arctic and other nice things. To explain the size of these, I used to explain them as the size of a phone book, but now I suspect some of us have never seen a phone book. We used to have these things called phone books. If you couldn't see over the steering wheel in your car, you'd sit on one. They're about the size of maybe 4 laptops glued together. So you've got quite a set of batteries in powering one of these devices. I do love feedback in class and questions, so if you have any questions that go along with your hand up, I'll be trying to extract feedback from people. It sounds a little painful, sometimes it is. Hopefully it's useful. So I do love teaching. I got into teaching because in industry, I really enjoyed it when new people joined the company and I could explain to them what we did, how we did it. Now that's kind of my job. So I'm excited for it, and I love the fact that it makes the world a better place, because I can help you write better code, you can go into the world and do amazing things with it, and make the world a better place with that. I do have my degree, bachelor's and PhD from SFU in artificial intelligence. I love playing video games like StarCraft, World of Warcraft, I used to play. My recent one I've been playing Horizon Forbidden West, playing more than I should have been. That's like I'm married with 2 kids. Their ages 9 and 11. And I'd like to also mention here that I recognize my place of privilege, that I have a job that's very reliable, and I've gotten here with a lot of privileges that have helped me. I did work hard to get here, but I want to use this place of privilege to help everybody have a successful semester. We're coming from diverse backgrounds. Some of us may be looking after children, we're grandparents, some of us may be working 2 jobs or 3 jobs, paying rent, some of us are from overseas, a lot of different varied backgrounds. And so I want to use this position to help everybody have a successful semester and feel recognized. I want this to be a positive experience. It's going to be a lot of work, but the course itself shouldn't be a barrier. You should feel respected and honored through it. My expectation of the course is just respect, so I'm going to give you a lot of respect. I'll come prepared. Every question anybody asks, I will try and see in it what's really going on. In a first-year course, it's interesting because people ask questions that don't really make sense. How many times does an if statement loop? It doesn't. But it's an easy thing to get wrong. And so when I'm faced with a question like that, I'll say, oh, great question. It's a lot like a for loop, but it only goes through once. So please ask your questions. You're not going to be the only person in the room who doesn't know it. Remember one grad class where it was on formal logic, and I was lost, like capital L lost. And one of my fellow students asked a question about, can you compare the ground clause of foreign logic versus something else? And I was in awe. I was like, how can you ask such a beautiful question? You know what those words mean? And in the ensuing half-hour discussion with the instructor, I learned all of that. I learned about it because the first presentation that the instructor gave didn't resonate with me. But in this interaction with this other student, and others joined in, I learned a lot. So please ask your questions. You're not going to be the only one in the class who doesn't do that. If you're sending me a message, give me a little bit of context on which class you're in, what you're working on. As a bit of a kind of a context here, if you're sending me on average more than a couple messages a week, that's perhaps more than I can really deal with all the time. There's always somebody in the class who's having the worst semester of their life, and I'm very much there for them to help them through that kind of situation. If you tend to have, you want to have kind of an ongoing discussion about every lecture material, come talk to me in office hours. I love that. I really can't handle that in an email from 300 students. Quick intro to the slides. Anything in green is probably a heading. Anything in yellow is something to take note of or highlighted. Blue I try to use for defining things. Any text that sweeps in is not going to be found in the PDF online. So on the course website I'm posting PDFs, so you don't have to transcribe everything. So, for example, there are 10 types of people in the world. 10 types are? Close. Those who get a binary and those who get invited to parties. It's a self-deprecating version of that. If you didn't find this joke humorous, maybe by the end of the semester you'll think it outrageously funny. So anyway, you don't have to copy this down. This will not be on the midterm. It might be on the final. Otherwise, things are there just to kind of try and keep people engaged. If you write it down, some of us will learn better by writing things down, so we'll try and make the important parts things you have to write down. To succeed in a class like this, oftentimes people are coming with all these different backgrounds. This class tries to be a leveling agent, to try and say, okay, there's all of these skills a lot of us are missing. This class tries to fill them all in. There are 8 initial assignments that are filling in the blanks with different skills. That's a lot. To get a lot out of this course, you're going to learn a lot. And to do so, you need this growth mindset. To think about, I don't know it now, but I can learn it. It's maybe the one important thing, most important thing for separating success from not in university. So, this is maybe obviously true. Programming is a skill a person develops, and not one that they're born with. Right? So, for example, it has never happened that a newborn baby programming the whole world. This doesn't happen. Nobody is born being good at C. You get that? Now, there's a corollary to this, which is perhaps the one that maybe some of us initially believed, but we maybe can hopefully realize it's not true, is that nobody was born being bad at C. If I were to ask 1,000 people who are in computing science, I'd probably get more people saying that they are just bad at programming, something like pretty low-level programming. I'm bad at this, I'm bad at that. You hear I'm bad at math. Well, nobody was born bad at it. You had to learn to be bad. So everyone who's good at C worked hard to get there. So that's what this course is going to take us through. As part of this, there are some dispositions that help kind of pick up these skills. So things like being collaborative, inventive, persistent, meticulous. These are things that can help you as a computer scientist learn new things. For example, meticulous, we have to be. We care about, you read a sign, up to, kids under 7 eat free. Okay? First I can read, well, under 7 years, feet, whatever, we talk about these sorts of things. And do you mean 7 and under, or under 7, and how much under 7 do you need to be? Right? These are the sorts of things as programmers, we care about those details. So as you're going through the course, realize that there are these dispositions, and you can learn them. You can develop to be more meticulous and train your brain to focus on those things. You can help train your brain to be a little more persistent and say, okay, I tried it, it didn't work, oh no, let me try it again. I know I need to try things 3 times before I do something else or something like that. Set the expectation for yourself to build these skills. Any questions, comments so far? Okay. Is the mic on? Because last time I got most of the way from my lecture, I had a testing. Audio test. Okay, good. So let's start with the elephant in the room. AI, generated by AI called Dini, a kind of a shifty-looking elephant in the room. Have an AI ninja headband, and make sure it's 800 by 800 pixels. Miraculously, I got it, right? We're not so impressed by this at home because we've been using it for a while. You go back 5 years, and this is like, wow, you've got a program that'll do that for anything you like in the world. That is miraculous. You're like 50 years, 100 years, and you are like godly power to do that. So this is amazing you can do this. But I will point out, I asked for 800 by 800 pixels, and it gave me 1024 by 1024. can forgive Picasso if he'd done that, right? But still, it was a direction it didn't follow. So maybe this helps realize that, look, this isn't the perfect solution. So the elephant in the room, of course, is that AI is dramatically changing software development. For good, for bad, ask me in 10 years, maybe 20 years. We know that it can quickly write some code, and it can provide a fairly good analysis of code as well, if you've ever tried it. So it has a lot of skills. These are skills that computing science students should have too. So if it's got those skills, then does this mean that software developers are obsolete? And perhaps the jury's out on that entirely and where that's going to go, but it's certainly, there's always going to be somebody using a tool. One of my colleagues compared it to when compilers came out. When compilers first came out, you no longer had to write assembly code, and it was like, wow, this is amazing, high-level languages. We don't need programmers anymore, because now anybody can use one of these high-level languages. They're so easy. Like C, a great high-level language is so easy to learn. Clearly not, right? So this is just another tool in our toolkit. So in certain situations, you will be able to use AI in your life, or you might be forced to use AI in your life. And to be an efficient developer, I'd say you need two things. One, so if you're an efficient developer with AI, you need to be a skilled software developer to start with. And you need to know how to efficiently use the AI tools. You still need that first skill of being a skilled software developer. One of my friends works with the Linux Foundation, and he says that this is a challenge they're trying to figure out now, is if so much of the entry-level stuff can be done by the AI, better than a really junior developer, then you need a mid-level or high-level developer in order to run the AI and do things effectively. We have a big barrier problem. That at the moment, there are some, maybe enough, mid-level developers, but that's not going to last for long. People retire. So how are we going to start getting junior people to be skilled enough to fill those gaps? So we need to build those skills, and that's something that maybe the world has not yet figured out the full answer to. So how does this fit in with this course? So why do you need development skills? Strong developers can more effectively use AI than weak developers. You've got to be able to look at what the AI gave you and understand right away, is this good or not? And you get that skill by being a strong developer. The AI tools will generate kind of quantity over quality. They'll give you a lot of code fast, and in fact, they can keep giving you different versions of it. You can ask another version, it'll keep kicking out different implementations of the same thing. Well, one of those is going to be better than the others, probably. How do you know which one to take, and what to do, and when is it going wrong? So you must be able to review the quality of the generated code, and you must direct the AI on how to make your goals. That's not something the AI can do on its own. You're bringing that as your added value. So you need to know good code and how to improve it. And so that's what this course is going to be about. It's about building your skills as a software developer. We teach a lot of the low-level tools, but we'll teach you how to interact with the stack, how the thing works. You've got to be looking at this and saying, well, I want to come out as the skilled software developer. I'm not just the AI operator. So in lecture, we're going to teach things. I'll teach you new ideas. You're like, oh, I've never heard of S-Break before. We'll cover that in 2 weeks. And here's how it works. It's nice. But the big package of being a developer is being able to use it. So in this, so I guess the question would be, how do you learn to write code? Have you ever read a book and learned entirely how to write code? Not many of us. Most of us are going to learn to write code by writing code. Writing a lot of code. And in assignments is how we're going to write code in this course. We'll do some in class as well, so we'll try and bring as much in as possible to class, but a lot of it's in assignments. So here's my coding process. I say our coding process, but it's really mine. First, I write a little code, and it's wrong. It's almost always wrong. But I then run it, and I'll see why it's incorrect. Say, oh, it should have printed out hello world with a line feed. It didn't have a line feed. I'll find in my code where the problem is, and then I'll decide how to fix it. And then what do? I could, yes, I should test, yes, very good, very good. Next, I test carefully. Well, running it is kind of my testing, so anyway, I'm going to go to one. I go back, I write a little code because I decided how to correct it, so I make the correction, and it's wrong, and then I run it, and maybe it's wrong because I simply haven't finished my assignment yet. I don't have everything in there. Okay, so we need to learn to be a good developer. We learn to be a developer by writing code, and this is our coding process. That's my argument so far. Where in here are we learning from? Now, one of the ironies of university life often is that you don't know people. You're literally in the same place as 150 other people, and you might know more than 2 or 3 of them. So what I want to do now is we're going to have people talk. Don't talk with somebody you know. You're going to find somebody new. Everybody in the room has to talk to somebody new, which puts us all on equal footing. A lot of us don't like to talk to new people. This is your opportunity to find somebody who needs to talk to you. And I want you to decide which of these first 4 is where you feel your learning is. Where does that really fit with you? So afterwards, we're going to do the ABCD to see what people think. But to start with, I'd like you to talk to somebody else, figure out where your learning happens. You have 2 goals. One is to learn their name and some way to contact them. Email, Instagram, carrier pigeon. And then decide for each of you, where does your learning happen? So you get 5 minutes to do that. We'll then come back together, we'll ABCD to see where we all think our learning happens. I'll wander around, chat with you on your questions. Okay, so go find somebody new that you didn't walk into the room with. If you're sitting beside them, you might not know. bring it together. What do we think? So for the ABCD questions, what I'll do is I will say, okay, so figure out your answer, and you can lock your answer, and I'll count it down. So in 5, 4, 3, 2, 1, what do you think? Where do you do your learning? I've got quite a few C's, D's, some A's and B's. We got a pretty good mix of where people feel that they learn in here. Interestingly enough, I'm not sure where I would answer. Right, I think that they're all pretty good. Anyone want to speak to what they thought about this? What came to mind when you did it? Yeah. Yep. Oh, I see. So not only do you recognize as a problem, but then like, what do I do different? And try to change. I was thinking this way. That's maybe the point. You change your thinking. I like it. Yeah. Right. Yes. Clearly. Okay, yeah, so kind of finding the mistake is a big part of that, and then you mentioned a correct way, because there's this whole space of ways you could solve it. I'm going to go with this one, and why? Yeah, one of the things, not so much in this course. This course will be a lot more kind of the low-level reasons on, okay, this failed, I need to do this so that it works. Some of my other courses, like I teach 213 this semester as well, we'd be talking about kind of looking at the high-level patterns of here's a design decision as to why this or why that, what is better. In this course, it's going to be a bit more of what works, what doesn't, but thinking that through is a lot of it. I'll take one more person's thought, yeah. Oh yeah, so like given a lot of code, how do you then understand it? How do you build on it? And so that you have to then start making little changes to it to figure out, okay, this is where it is, how does it fit? Yeah, I worked on LibreOffice, which is the tool I'm using to project here, a bit at one point, fixing a few bugs, and it was a huge amount of code to try and get through. I needed a bunch of help trying to figure out where in the system I should start working in. And so, indeed, finding your place in that is really hard. Okay, so can you see where we're going with this? That to have value, you need skills. To get skills, you got to learn them. We learn by coding. Here's our coding process, where we probably learn somewhere in there. And then I'm going to say, what's the impact of AI on this? So if at any point you're using AI to do this because it's hard because you're learning, right? People ask me, how long will it take to do the assignment? I actually have numbers for this course because I pulled the previous offering. But oftentimes I'll say, well, to redo this assignment might take you 2 hours. So there's 2 hours of coding in this assignment. And then there's 4 or 6 or 16 hours of learning. That's I tried stuff and it didn't work. I didn't know what to do and I figured it out. So I spent 16 hours learning and 2 hours coding. So if you're stuck, short-circuiting the learning isn't a great opportunity here because AI can do a lot of this. I haven't tried it yet. I'm planning to try all of the programming assignments for this class, running through as much AI as I can to see how far it gets me. But if you did that, you're probably going to learn as little as possible, right? It maybe saves time on the assignment, but it also minimizes your learning. So what are the limits of AI? So first, if you're trying to learn with AI, there's a good way and a bad way. And the bad way is, dear AI, please do the work for me. It's like having a paid person write your code, except you're not necessarily paying a person, you're getting a tool to do it. So write my code for me. I don't want to learn this. It'd be like paying someone to diet for you. That's not going to really help anything you want to do. So AI tools can disengage you from learning. Used incorrectly, they will just do the work for you. Okay, write me a function that processes a C string and counts the number of apostrophes, but handles escape sequences. Okay, that's an interesting little problem. AI could probably kick out the solution as fast as I could have said it. You can, in fact, copy and paste from Zoom, and it would then automatically get it. In fact, one of my colleagues described that it was faster to take a picture of the screen than to copy and paste. So you take a picture, pass the picture to the AI, and then hand back a solution. But that stunts your growth, your intellectual learning. Right? And that's what, honestly, you're paying a lot to be here in time and money to learn from this course, and so AI can really kind of steal that from you. You probably know that AI mostly understands, most of the time, on many things. There's always the things it doesn't get. So I asked it to refactor some code for me very recently, and it was in Java. I had an interface with a couple methods, and I wanted to implement it in a couple ways. And the AI tool told me, quite right, that with an interface, there's a couple ways you can do that. We talked about in the Java courses. But the ideas it was giving me didn't really apply to my code. It kind of knew that. So it told me all about these 3 different ways that I could have used an AI an interface. And then it gave me the identical piece of working code for each of them. It says, you can solve it this way, here's your code. You can solve it this way, here's the same code. You can solve it this other completely new way, here's the same code. And I knew what it was doing. I could see through it like, oh, it's thinking of this. And it told me these things. It gave me kind of a 60% answer on the final exam. I would say, yeah, I'm going to give you 60% because you knew these ideas, but you couldn't just bring it all together here. So yeah, I got 60% on that question. And I knew what was going on because I knew about what it was talking about. If I didn't, then I wouldn't have added any value. So you need to be the person that adds value to the system. And again, AI is quantity over quality. Some open sources or projects are banning AI contributions because anybody and their dog can go to the computer, pull up the source code, say, dear AI, please add the following feature. Great, now submit it to the developers for addition to their software. Of course, it's garbage. A lot of the changes are garbage. They're unmaintainable garbage. And so now you're having your senior developers, your experienced developers sift through reams and reams of garbage pull requests looking for the gems about here's a good idea that's well-coded, that's maintainable for the future. Also realize that the benefit of AI is an active area of research. It seems sometimes like a slam dunk, and it's not. Sometimes people's opinions are that it's much, much faster for them, and it's actually slower. Other benefits, depending on who you are and where you are in your learning space about how much you know the project, or the code, or development, it makes a big difference. So at the end of the day, you need the skills, and you need to build those skills. AI can help be a tutor, but it can very much steal the learning from you. So for this course, what can you do? You can have your AI system explain code to you. I don't know what this is doing. Explain it to me. Great use. You can have it quiz you on content. Like, what are the different ways of using SBreak? And when would I need it? Or you can ask me 5 multiple choice questions on SBreak. You can probably come up with some pretty good ones. If you come up with a great one, send it to me. I'll see if I can put it on the midterm. And I'm okay with using AI tools when you're really stuck. Like if you would have called up your friend who's done a lot of programming before and say, hey, I'm really stuck with my code, using an AI tool then to kind of bump you along is great. But rather than telling it to give you a solution, make your prompt be like, answer as though you're a tutor, trying to teach me how to do it, but don't give me the solution. Guide me through understanding it, that kind of thing. In fact, a lot of work has gone into by universities like Stanford and so forth about building their own AI agent that is basically using ChatGPT or something like that with this kind of master prompt to guide the system into giving a helpful response that helps the user learn. I'm also okay if you use it for things, very low-level things. Like, for example, have you ever written anything random number generator with C++ that you didn't use RAND for? So RAND is great, fast, and easy. It's nice for a little toy app. But if you're doing something cryptographic, RAND is garbage. So you end up needing to use these other things. And there's like a random number generator, and you put in like some generator, and then there's like a number there that defines the, I don't know what it's defining. Anyway, you look at this code, and it's completely impenetrable to me. I've looked at it, I've taught it, I just don't really get it. So I'm just going to go to Stack Overflow every time, and I'm going to find what it is, and I'm going to use that idea. So I'm okay with using AI kind of in that direction. Now in this course, you cannot copy and paste anything. I'll say that one more time. You cannot copy and paste anything. And we have tools in place to detect for it, and we have a 5% deduction on an assignment for each time somebody copy and pastes. So don't do it. We'll tell you how to disable it. You just don't want to do it. You have to type it in yourself. That's at least a good start. Don't use AI for things that will steal your skills. Don't let it make design decisions. Don't let it write your code. And don't let it refactor your code. These are the skills you need. Don't rely on it to do it. When you are a senior developer, sure. Give me some design. One of my friends works in a VR gaming company. He said that some of the developers were using AI to kind of give them 80% of the code for something. They're trying to interact and change data between one format and another. AI can maybe give them 80% of the code really fast. And they've got the experience to know what to do with the rest of it. But to start off with, we don't have that experience. We're not going to let it steal the learning from us on these topics. Any questions on AI in general for how it's going to play out in this course? Yeah. Yes. Okay, so inside, we're going to use an editor called NeoVim. Inside of NeoVim, you can select and you can grab, basically cut and paste and copy and paste inside NeoVim using NeoVim's support. That's fine. What you're not allowed to do is go to your web browser, select the code that ChatGPT gave you, right-click to copy, go into your program, right-click, paste. We will catch that, and we will take off marks for that. And furthermore, just stole all your learning on that. So that's what we're objecting to. But yeah, you're refactoring your code. I don't expect you to read, I want to move this function 7 lines up. Let me just retake the whole thing. No, that's archaic. I can do that. Thank you for that question. So yes, how many people know of somebody who's written, I'll say 90% or more of an essay using AI? It might have been you, or it might have been your neighbor. How many people know of somebody who's written most of an essay using AI? A fair number of us, okay. Have you ever actually read an AI-generated essay? Oh my god, it's soul destroying, right? It's very flowery. I had somebody turn in a report once. It was all flowery. It was very well written. The prose flowed smoothly. And it talked about this thing that had never happened. This tool has been tested in the following environment. No, it hadn't. And it had been proven to work. Nope, nobody's ever run it in the field. I knew this. It was a tool we wrote that semester. I don't know why they gave me this essay. I don't know if they even read it. It was garbage. So if you're going to, I object to also emails. If somebody sends me a long email, that tells me that they probably care about at least, hang on, 5 years ago, somebody sends me a long email. They probably cared a lot about the topic to write me a long email. Now somebody sends me a long email, and I'm thinking to myself, did they write it? Or did ChatGPT, right? Hello, Brian, honored Brian. I trust that you are doing well today and hope that the rest of your day is also amazing. Please, thank you for your previous response, and I am glad with your tutelage, and it's all garbage. That was probably from AI. So just send me the prompt. If you're going to use AI to generate something for me, just send me the prompt, and I'll look at that and be glad of it, right? That'd be fine. I can tell people now I'll give them 2% if they send me the prompt. I'll give them 0 and write them up for academic dishonesty if they give me the essay they generated with that prompt. So we don't have to write any essays, so we're fine. Okay, let's talk about system programming. What are we talking about in this course? So system programming is low-level programming that directly accesses either the hardware or, more commonly for us, the operating system. Everything you've probably done so far, in like your algorithms course and so forth, you're just using C in and C out. Maybe you read from a file. Maybe you use some sort of framework to do a REST API. These sorts of things we teach in other courses, how to do things. Maybe use some sort of library to access a database. Those are great things to do, but we're talking lower level here. We want a program that gets more memory from the operating system. How do we do that, specifically in Linux? That's a lot of what we're going to look at in this course, is the ways to interact with the operating system. So there's a number of languages we could use. In systems programming, we need something that can manage memory. Manage pointers, access, getting more memory, freeing memory. So we need to use something like C, C++, or Rust, are all system-level programming languages where we can actually manage that memory. Things like Python and Java, they're great languages, but they do it all for us. They're suited to a different set of problems. Next thing is, what did they write the Python interpreter in? I don't actually know. C, could have been C. It's more likely to be C++ now. I'm not sure what it is. It wasn't Python, right?
It wasn't Python, right?
Oh, okay. Reference implementation is C. Cool. So you really can't write the interpreter in the language you're trying to interpret, right? So it had to be written in something. That's kind of an idea of where C or C++ or Rust would fit in. Now, we're our group thing. I'm going to just skip over this so we always talk to each other. Here's a course overview. What cartoon is this? XKCD. Yes, it's XKCD. One of the primary values of a computing science degree is that you will understand XKCD cartoons. So this is describing your course for us today. True story, week 1. Hey, it's your cousin. I got a new computer, but I don't want Windows. Can you help me install Linux? Sure. We do. It says my Xorg is broken. What's an Xorg? We're going to look that up. Let me show you man pages. I'll show you man pages today. That's it. Week 6. Due to an auto-config issue, I'm leaving Ubuntu for Debian. Or Gentoo. Week 12. You haven't answered your phone in days. Sleep. Must compile kernel. Too late. So parents, talk to your kids about Linux before someone else does. I'm someone else. This is actually a very, very accurate description of Compute 433 as well. We are not going to get down here to week 6 and 12 into those weeds. You don't need to recompile the kernel. In fact, you can't. We're providing a whole dev environment for you, prepackaged. You can't change it. But we are forcing you into that first kind of Linux world. So our goal of this course, be a confident developer with low-level operating system services. So be able to really use what the OS provides to make those low-level tools. This course is very applied, and it may involve spending hours solving things like build issues and debugging complex behaviors. I say may as though it might not happen, but it clearly will. Anyone who actually does the assignments will spend a lot of time on that. What's going to be in the course? So the first level is understanding user-level services of the OS. So we're not delving into the kernel. That's OS. Is it 301 now or something like that? Say again? 303, okay. We used to have an operating system called 300, and it's split into this course and the other 300 level OS course now. In that course, you actually get into things like the kernel, how does the kernel do these things? We are just saying, hey, the kernel does all this, let's use it. So that's understanding the user-level services, and we're going to focus a lot on writing low-level programs using those services. We want it to be correct, we want it to be efficient, within reason, and we want it to be reliable. So we want to write reliable C code, which is its whole game in itself. So, we're not actually, so why don't we do this? We'll do this ABCD. How would you rate your programming ability today, compared to where you are in your degree? If you're a second-year student compared to a fourth-year student, you've got maybe a different bar as to what you think you should be at. But compared to that bar, are you excellent, good, okay, or poor? In 3, 2, 1, what do we got? We've got quite a few C's, a couple of D's, and some people are B's. And I don't think I see a single A. Okay, so either we're humble or accurate or whatever. Anyway, we all have room to improve, clearly. My next question then becomes, how good would you like to be at the end of this course? And we don't have to do this with ABCD app here, but just think about that, about what would you really like? This course is hands-on, incredibly applied. What would you like to come out of it with? And really, it's going to define what you put into it. This course isn't going to magically make anybody a better programmer, but if they spend a lot of time coding and carefully thinking about it, they're probably going to get better. So if you felt yourself to be a C, maybe you come up to a B or an A. You realize, hey, I can do this. So my hope is that this course helps everybody move up by putting in the have to put in effort in. And then there's that realistic thing about how much work are you willing to put in to make that happen? How much can you honestly do? Do you have time? Maybe you've got 2 jobs and a family to look after. Maybe it's a huge time commitment and this semester that's not going to work. Or maybe you're busy, and we're all busy. Can we make this work? Can I make the time for this to happen? And a large part is, can I focus on getting it done? Can I be active? Can I be proactive at getting things done a little bit ahead of time rather than being all behind? So Compute 201 is a 4-credit course, and we will use all of those 4 credits. Not only does it mean we have 4 hours a week in lecture, but also we have enough content to otherwise take up that time. SAT says, I think, 3 hours of time per credit hour or something like that. This course is probably guaranteed to fill that available space. There's a law, I can't remember whose it is, that data will expand to fill available space. So will this course. So it'll kind of take up additional time. And look at how are you going to get through it? Do you have a lot of time, and you can manage that? Do you have an average or minimal amount of time? Or are you looking for AI to do it all for you? Which we talked about where that's going to get us. So that's kind of a bit of perspective. What goes into this course? Well, there are going to be 11 labs. The labs are not worth much. The labs are mainly there to help everybody build the very base level of skills. Lecture, we'll talk about it, gives you an idea. And then labs are that first step up. Doing something, compiling it, writing the code, playing with it. That's that first step on that kind of the first couple passes through our iteration of coding. And then we'll get into assignments, and assignments will be more work. The first 8 assignments, which are 0 through 7, I think they are more programming. We call them the short assignments. They're all tutorials, most of them. And you'll follow a tutorial on the terminal, another one on Clang, those sorts of things. Different tutorials we need you to know. And so we got labs are maybe 2 hours of work each. The first short assignments are maybe 2 or 3 hours, 3, 4 hours work, depending on your background. And then long assignments, and we're not kidding. We call them long assignments. So we got a little step and a bigger step, and then we do one giant leap for programmer kind. So the long assignments are orders of magnitude more work. maybe one order of magnitude, maybe 2 orders of magnitude more work. So they are a lot going into them. They are not going to step you through how to do them. They give you a problem you've got to solve, and you've got to build up how to do that. We've got lots of resources to help you. I think we're going to have about 30 hours of TA time a week doing office hours. We're going to have in-lab and we're going to have on Discord time. Plus, there are 2 sections, and people from either section can go to either TAs for help. So there's probably going to be 50 hours at least of TA time available per week. You can go and make use of their office hours. Yeah? What about the in-lab stuff? So I'm going to have our TAs before and after class on Monday and Wednesday be in the lab in Surrey in the other building. And that's a really great time because you're here anyway. In Burnaby, I'm not sure what the timing's going to look like there. You're welcome to go to anyone's in-lab office hours, talk to any TA. There is a caveat there that if the TA is swamped, they may put up a only my section kind of flag saying, today I'm only helping my section because there's an assignment due tomorrow, and we kind of want to manage those resources fairly. Good question. Yeah. Yeah, so we used to have scheduled labs. It was a gong show in Surrey because people had to get here. Some people came for lecture, went to Burnaby, came back here, and then went back to Burnaby. It was terrible. So the labs are online already. They're about 2 hours worth of work, and you can do them anytime you like to do Sunday. You submit the code online. We mark it not by running it, but by glancing at it. Does this look like it could be a solution? If so, check, you get your mark. So we're not really sticklers on that. The hope is that a lot of people will be in the lab using TA time. The TAs at the end of every hour, in Surrey at least, will show you the solution to the lab. You can pull out your phone and take a picture. Don't send it to your friends, they're just freeloading off you. But the idea is you get lots of help. There's like an unlimited amount of help there. We're showing you the solution if you want it. We're happy to walk it through. The TAs can be there. You can ask them 50 minutes of questions. You can go for 2 hours straight before lecture and 2 hours after lecture and get unlimited pretty much help in the lab on those lab exercises. But you don't have to. You can do it all on your own. You can work with a friend. The labs can be cooperative. You have to type your own solution, but that's about the only requirement. And we really can't check it anyway. Any questions else? Yes? Do you need a fob to get into the lab? Yes, so the Surrey ones will probably be unlocked. I think because you're taking a class in Surrey, if you've already got the fob to get into the Burnaby labs, that fob will work here as well. Do I know where you can get one? Of course I know. This is kind of my, no, I have no idea actually. Exactly what he said. The Discovery Building, I'm told, in Burnaby. In Surrey, there will be options as well. If anyone does need to get access to the lab, maybe send me a message on either Discord or email, and I will find that out and I'll put that information on the course website. Yes? Okay, so we're told you can ask the security and they'll get you the fob. It should automatically add you to those labs if you're taking a course in Surrey. So if you are enrolled and the door doesn't open, let's say the door doesn't open next week for you, let me know. I'll at least make sure the TAs can get in, and so the TAs can open the door for you. So bare minimum, everyone give them the room, but we will make sure that everybody who's got a fob in this class can get through there. And so we'll keep nagging the people that need to know. Our IT people are amazing, so they will definitely go to bat for us to make it work. Okay, any other questions so far? Love it. Okay, on your background too. If you've used a Linux terminal before, you'll probably get this done much faster. If you either haven't used a terminal before, or you're really going methodically through it, trying to learn the maximum amount, it's going to take 5 or 6 hours. It took me 6 hours to do it, even though I taught courses using Linux terminal before. So a lot of these are based on your background, how much time it might take. And that's not to say that you don't know what you're doing. It's just like, well, maybe I've never used this tool before. I've never worked with this before. And so forth. Through all of the 8 first assignments, we can see that we kind of have this peak around 3 hours. The question I'm always interested in is not necessarily just how long it took, but was it valuable? So if it took you, for example, 20 hours to do it, I'd want to know, was it valuable to you? Do you feel that you learned a lot for those 20 hours? And someone might say, yeah, it was great. I really did learn a lot of information from that. Or someone could feel like it was a complete waste of my time. So that's what this graph is showing here. I asked for each of, in opposite order, 0 through 7 going up, how much did you like it? So blue, dark blue, a lot more time. So that does tell me I need to force you to develop with a set of tools in a particular way and teaching you those skills. Now that's intentional because oftentimes graduates, you'll be able to jump around and do those kind of things. So what are we teaching? We're talking about Microsoft for 1 semester and working on Windows. It crashed. And everyone was running the same version. It crashed. It locked up. It automatically sends a message to the list saying, hey, we got a locked up system here. Go debug it. So I got told to go debug it. I had no idea how. So I went and talked to this other guy. And he's like, oh, let me connect. So he connects through his terminal. And he's going through his terminal text debugger. And he's looking at the code. He's like, oh, let's go off the stack. Oh, here we got a null pointer where the null pointer comes from. There. I was like, oh, wow. So hopefully by the end of this semester, you'll have some of those skills. You will be proficient on the command line. You'll be able to jump around and do those kind of things. So what are we teaching? We're talking the command line interface. So we'll do some shell scripting. That's one of the assignments. We've got processes and threads about how we do things concurrently. Compared to a person who got a C- in the prerequisites. They can both be in this class. One of those people will probably have a harder time in this course than the other. Drew used that they now needed big files. You can see what plugins are there. We are checking for activity dishonesty. We are checking for copy and paste on those things. And new this semester, actually, we're going to have quizzes based on that. We'll talk about that in just a second here, about the assignments. The labs are only worth 4%. So not worth much, but are very helpful. Everybody should get those 4%. That should be an easy way to get it. And the breakpoints for different letter grades may not be standard. Computing science actually has no standard. So each instructor sets their own breakpoint. So what is an 86? Is it an A minus, A plus? When people who cheated got the marks that everybody else did. So somebody cheats in the class and gets the same mark as somebody else. So we will do all that we can to try and find the people who cheated and then give them zeros. On that note, AI really messes this up. So from an education point of view, I want to give you credit in the course for the important work. The important work is not the midterm, and it is not the final. The important work is the assignments. So we get 10% on those. I'd love to get more percent on that, in fact. We are heavily weighting it already. But now with AI can do most of the assignments or a lot of the assignments, and it will really reduce the learning that people would have to do if they chose to do that. So what we're going to do is we're going to bring in quizzes. Quizzes are worth nothing. What the quiz will do is it will unlock a higher grade possible on the assignments. So for assignments, say assignment 8, which is one of the long ones, the maximum grade that somebody can initially get is 50% on that. If they don't write the quiz, they can get at most 50% on the assignment. They then write the quiz, as everyone in the class pretty much must do, and if they do well on the quiz, it unlocks a higher grade on the assignment. Hopefully 100%. And so you get 100% when you submitted it, you did quite well on the quiz, meaning you got either, say, 5 out of 6 or 6 out of 6 on the multiple choice quiz, and that unlocks 100% of the grade for the quiz, or the assignment. That's the idea. Now somebody who maybe used too much AI, maybe their assignment passed all the tests and was perfect, but they didn't know how to answer the basic questions on the quiz. And so maybe they got 1 or 2 on the quiz. So if they got a 1 on the quiz or a 0 on the quiz, they can at most get 50% on that assignment. It is multiple choice, so you should at least get 1 on a 6-question multiple choice. If they get a 2, well, that's unlocking like 68% or something like that of a grade. And so it scales up. It's designed to be a little bit forgiving. We're not bringing it down to 0. And to get a perfect 5 or 6 unlocks the top end as well. These questions are going to be based directly on the assignment and the assignments only. So we're not checking the whole content in the course. We're just saying, okay, we asked you to write an assignment on memory management. All of the assignments are 100% auto-graded through a GitLab auto-grading script. And there's no mystery here. You are also given a version of the auto-grader as part of the assignment that you download to start with on GitHub. And so you code it, you run the tests, and if the tests pass, you pretty much know you've got a really solid implementation. We may have a few extra tests that we do, so we can't guarantee you get 100% there, but if you're getting 100% as you run the tester on your local build, you're probably going to do really, really well on the assignment. No mystery on that. Yeah? As long as you also did the assignment. But we'll try that, we'll see how it works. I want everyone to leave the quiz going, that was fair, and that covered the right kind of things, and that was reasonable. For the late policy in the course, you have 7 late days to use throughout the semester. They're billed by the fraction of a day, so if you submit one assignment an hour late, that costs you 1/24th of a late day. You can submit up to 3 days late on any assignment at max, so you can kind of split your 7 late days any way you like. We will automatically do this, you don't need to tell us about it. We've got scripts that will automatically figure out how many late days everyone has left. In the summer, we ran it with 14 late days, which we decided was too much. The average that people used was about 7. So it kind of peaked at 7, and some people it was like a bell curve then. So we were saying, well, we're going to go with 7 late days. It is built by the hour, kind of built by the fraction of a day, down to whatever our floating point handles. So there's quite a bit of flexibility there for you to do that. Remark policy, if you don't agree with what the automatic system gave you, you can talk to one of our TAs. Right. I think off NeoVim, I think the initial tutorials, that's the thing that hit people before. Pull it from GitHub again, and then you've got whatever you pay. On Discord emails, you'll run these point where you can kind of figure out what you need to do. For each assignment, we're going to give you a README file like this. I recommend, in fact, the guide will tell you. So I'm going to make a folder here. T, I love T. So if I was going to be doing an assignment, I would start by, actually I've got one already, let me just use that. I cloned it before I came today. Under Units, under 02 Tools, here is the first assignment, A0. It's online now. I can use the Glow tool to read that file. Good enough. And this describes what you have to do. Basically, it says there's a tutorial online, go follow it, and then we're going to mark it. In order for us to mark it, you have to type in record. So you say record. This executes our keylogger. Anything that we now type into this terminal will be written to that keylogger, but only this terminal. Anywhere else on your computer, you log into your Hotmail account. You have a Hotmail account? You can kind of tell how old someone is by their email address. Hotmail? Ooh. Yahoo? Ooh. Gmail, you're probably at least in the right century. I actually have a Yahoo account as well. I've got this, so anything you do outside of this terminal doesn't get logged. So now inside of here it says recording, so everything I type is going to be written into, let me do an ls-a. You'll learn what this is by doing the tutorial. ls-a shows me all files, and we can see here, has it written it yet? This .record folder. Everything that the keylogger takes gets put into files in here. Some of it only gets written when you stop recording, so when you're done and you're finished, you want to submit your work, you'll have to stop recording by typing exit. And now we have left that. If I do a git status, again, all of this is in the descriptions. It says this is a record file. Let me go look at that record file. These are the things that the keylogger detected. We can look at this. For example, let's look at the cat input 0.snapshot. That's what it records to us. All keys that were pressed, all things that went into the screen. Again, no magic here. So I'm going to go back. anytime you're going to record, you want to be in the root folder of the thing you're doing. So I'm doing assignment 0, so I'm in the root folder of assignment 0. I'm going to say record, and it's now going to start recording more stuff, and I can do whatever else the tutorial tells me. It's going to tell me to create a file or something, so I can assigned to the you either want to run the, I'm going to copy, I'm going to go back to my terminal, I'm going to right click, and I haven't yet set it up on my machine to not, so it'll automatically insert it. In the guides, we'll tell you how to disable the automatic insertion, the automatic copy paste. So now I'm going to write that, so in fact I can even just forget that. I can go control, get out of this, and then I can just quit exclamation mark to not save the file. So I didn't save it even though I copy and pasted. I'm going to exit the recording, and now I'm going to rerun that and delete the entire recording folder. And so now, when I rerun my checker, it's got nothing to look at. So it's like I just restarted the assignment. Yeah. As long as you've recorded 80%, I'm fine. Where 80% is defined somewhat loosely. If you did a lot, you should probably then turn the recording back on. It will tell you that the recording is happening here. Get in the habit of looking for it to say recording. So let me go back. I have lots of great questions. I do want to get through at least the rest of these little bits of slides today. There we go, last bit of slides. Save them, maybe. Plan to get it done early. Produce that. I want to show you a bit more about the terminal just before we sign off here. A lot of people will do their entire assignment in one terminal. That's not actually a very effective way to do it. You want to set up with run extra terminals. So I'm going to run a new terminal here. A terminal for my editor. Tried to done. If you have any questions, come talk to me now. Otherwise, I'll see you on Monday. Thank you very much, everybody.